Before the first stone was laid for a temple, before the first grain was traded in a market, there was the tally. Nature does not present itself to us as an equation. It presents itself as a chaotic, overwhelming stream of variables. For our ancestors, survival depended on pattern recognition. The ability to distinguish between one predator and many, or to track the cycles of the moon to predict seasonal shifts, was the first primitive application of mathematical thought. This was not math as we know it, abstract and symbolic, but rather a biological imperative. The first ledger was not written on parchment, it was etched into the human neural architecture. We began to quantify the world to tame the terror of the unknown. When we moved from nomadic foraging to structured agriculture, the necessity for math shifted from survival to governance. We needed to measure land to settle disputes, track livestock to manage wealth, and document the passage of time to ensure the survival of the harvest. Math became the invisible scaffolding upon which society was built. It allowed for the birth of property, the necessity of trade, and the inevitable complexity of hierarchical civilization. As civilizations grew, so did the ambition of their calculations. The transition from counting physical objects to manipulating abstract concepts was the most profound leap in human intellectual history. In Mesopotamia and Egypt, math evolved into a tool for grand design. Engineers calculated the geometry of pyramids and the hydraulics of irrigation systems, realizing that the physical world followed rules that could be codified. This era marked the shift from how many to how much and how far. Geometry and trigonometry became the languages of empire. We see this in the architecture of the ancient world, the precision of stone alignments, the sophistication of celestial calendars. By developing the concept of zero and the place value system, we unlocked the ability to compute at scales previously unimaginable. We were no longer merely observers of reality, we were becoming its architects. This period of human history reveals a crucial adaptation. We ceased using math solely to describe the world and began using it to impose our will upon it, organizing the environment to suit our long-term survival. By the industrial age, the ledger had grown to encompass the mechanics of the universe itself. Newton and Leibniz provided the calculus that allowed us to model motion, change, and force. Suddenly, we were not just measuring distances, we were measuring the behavior of the physical realm. This allowed humanity to solve problems that had been barriers for millennia. How to harness steam, how to structure materials to bear immense loads, and how to transmit information over vast distances. The human brain, having evolved to track resources, was now optimized for complex systems engineering. We built machines that mimicked the precision we once had to perform manually. We created algorithms to navigate the seas, to organize global logistics, and to define the limits of structural integrity. Every skyscraper, every bridge, and every medical breakthrough in the last 3 centuries is a testament to our reliance on mathematical modeling to overcome the limitations of our biological cognition. We externalized our need for logic, building it into the infrastructure of our cities and the engines of our commerce. We have arrived at a new horizon. Today, we are no longer just using math to solve problems. We are using math to create the process of problem solving. Artificial intelligence is, at its core, the ultimate extension of the first ledger. By utilizing neural networks and massive data sets, we are teaching machines to identify patterns with a speed and depth that far exceeds human capacity. We have entered an era where AI generates art, optimizes energy grids, discovers novel drugs, and predicts economic shifts, all through the language of probability and calculus. Math has evolved from a tool we hold in our hands to a system that functions as an auxiliary mind. We have succeeded in our ancient goal to remove the terror of the unknown by quantifying every variable. Yet, this brings us to a philosophical precipice. As we delegate more of our decision-making to the algorithms we have written, we must ask, are we still the masters of the ledger, or have we finally created a tool that understands the mechanics of reality better than its creators? The journey from the notched bone to the synthetic intellect is complete.